Alrighty. In this video, we're going to take a small break from putting our MS build script together because you'll notice that if we look at our build script, right now we're sitting here at copy Photon servers to proper folders. But in order to really test this, we're going to actually have to have a bit of a Photon application running so that we can ensure that things are connecting to the proper places. Basically, what we're going to have to do is get Photon installed and then write a very basic Unity application that just, let's say, just connects to a Photon server and receives a message, or maybe it connects to the master server location, receives the address to the region server, connects to the region server, then gets a message. Basically, not anything that any code that we're gonna keep around, but we need to actually fill these projects out, the server.master and the server.region, so that we can test to ensure that our deployment pipeline works properly. So this video is going to basically be installing Photon, getting it running on our local machine, then putting together a basic Unity application that takes advantage of Photon to connect to the proper places. And then after we get that done and working, then in the video after this, we'll actually talk about the process of using MS Build to deploy those two servers. But that's going to open up, like I said, that's going to open up a can of worms because we need to then deal with configuration. And what I mean by that is our master server, for example, is going to need to know the region servers that it can connect to, or the region servers are going to need to know the master server that it connects to. And those server addresses are going to change depending on if this is a local build of our project or a production build. Remember, since this whole process of building an auto updater and doing continuous integration revolves around being able to deploy this to multiple environments, multiple development environments and one production environment, we're going to have to ensure that all of that stuff is configurable. So I can't really talk about all the configuration options that we can put together until I have an example of this stuff actually working. And to make this stuff actually work is going to involve actually installing Photon and getting a basic application ready. So let's go ahead and do that. Jumping over here into Chrome, if you head on over to exitgames.com / your country code / on-premise, you will see this page, and this is going to be the server platform that we're going to be using for the MMO. So it's available right here in this drop-down, learn more, and we can see this whole cool stuff. So what this is this is a version of Photon server that we can deploy to our development machines or to a specific server environment. So that's what we're going to use. What we need to do is we need to download the SDK, and the SDK is going to be what allows us to host a server, whether that server be in development or in production. To do that, you locate the Download SDK button, which is somewhere on this page. Up here on Developer, this little drop down, you can come up here to Download SDKs. Click on that. You will be asked to log in. You could go ahead and, if you don't have an account yet, you can create one. Just click on this little Create One link. It'll take you to a standard registration form. Do that, get your account, come back here, and then sign in. So I'm going to go ahead and sign in, hit Remember Me, and you will get this page. Now, we're going to need to download a couple things. We're going to need to download the Exit Games Photon Server SDK version 3.4.22. I guess that's the version we're going to use. Then we're also going to need two client SDKs. I'm going to want to grab the .NET SDK right here, and I'm going to want to grab the Unity SDK right here. They're both written in C#, but you'll need to use the Unity version of the SDK to work with Unity. You're going to need to use the .NET SDK to work with non-Unity projects. Although for right now, I don't see us using any non-Unity Photon projects for the moment. We will need to be able to write applications that can interact with our server that aren't written in Unity. So you will have to download both these SDKs. So I'm just going to download them all right here so we can get this page out of the way and show you where I want to put all the stuff. So first of all, I'm going to go ahead and click on this. It's the Exit Games Photon Server SDK. And that's going to start that download. It is an executable, but it's a self-extracting zip, which we'll see here in a moment. Then I'm going to click on Photon On-Premise.NET SDK. Then I'm going to click on Photon On-Premise Unity 3D SDK. And now I have these three things downloaded. So the exit games Photon guy, because I'm going to go ahead and actually unpin that, so ignore that. I'm going to go ahead and click on that. And again, this is a self-extracting zip file. So what I'm going to do is I'm going to find a location on my hard drive where I want to place this. So what you're going to want to do is open up your File Explorer, find a good location. I have a handy little software folder where I dump software that doesn't have installers. I'm going to name this folder. I can't remember if the self-extractor will create a new folder called Photon SDK or if it'll just straight up dump everything into the folder that we specify. So to be on the safe side, I'm going to create a new empty folder on my hard drive, and I'm going to name it Photon-version, what is this? This is version 3.4.22. So let me come back and save Photon-v 3-4-22. So now I have this folder right here. It's just an empty folder. I'm going to take that path, I'm going to paste it here into the 7-zip self-extracting archive and hit extract. And I made the right call because it looks like it just dumped its contents directly into this folder. So that is a good thing because I wouldn't want these folders being inside of my software folder root. Okay, so we've already actually talked about Photon quite a few times. You can go look at RuneSlinger if you want to learn more about it. But just a basic rundown of these 4 folders. We have our deploy folder, which contains our binaries for both the Photon applications, the individual applications that we are running in Photon, as well as the Photon application itself. And the Photon application itself is going to be located in bin Win32, Win32XP, Win64, Win64XP. Now, because I am running, of course, on not XP, and I'm running on a 64-bit operating system, to avoid confusion, I'm going to delete all of these folders that are not bin Win64. And I can show you guys, if we jump into bin Win32, we see this. If we jump into XP, we see this. If we jump into Win64, you see it's the same stuff. It's just the binaries are at a different operating system support level, as well as a different bitness. So I'm going to be using the bin Win64, and again, to avoid confusion, I'm just going to delete all 3 of these, just straight up permanently delete them. So now I only have one bin folder called bin Win64. The next thing that I'm going to do is I'm going to take this Photon control and I'm going to stick it on my taskbar. So we'll just stick it right there, and that'll make it very easy for me to launch the Photon control in the future. So just remember that the Photon control is what we will be running in order to start and stop Photon. Photon itself will be, in this case, ran as a, not as a service, but as an application from within the Photon control process. We don't need to do anything more when we actually go ahead and deploy Photon to our production quote-unquote server. We will install it as a service, but that'll be an exercise that we'll go through later. Backing out of this folder, we'll see some other interesting things. First of all, we see our bin tools folder contains a bunch of cool stuff. Really, the most important thing out of this bin tools folder is Beartail, which is a nice little log viewer. Then we also see Counter Publisher, Light, Light Lobby, Load Balancing, MMO Demo, and Policy. These are just Photon applications. So our Buzz MMO master server and Buzz MMO region servers will live inside of one a folder inside of this folder. Okay, so I think that that wraps up our deploy folder. We have a standard documentation folder, which contains documentation. We have a lib folder, which contains the library files that we will be bringing over into our Buzz MMO Server Master, Buzz MMO Server Region projects. And you'll notice that they do actually contain a Photon 3.NET DLL as well as a Photon 3 Unity DLL. I don't know if they did this before, but I guess they do it now. So those 2 additional client libraries that we just downloaded are included in the SDK apparently. Then we have Source Server, and Source Server just contains the sample applications that we saw before, but in source code form. So you can look at their MMO demo, their light demo, their light lobby demo, and all that fun stuff. So now that we have this done, what I need to do is I need to be able to build from Visual Studio and have these BuzzMMO Server Master and BuzzMMO Server Region files deployed directly into Photon. So this is going to require a couple steps. First of all, I need to actually write the BuzzMMO Server Master and Server Region applications, at least the bare minimum required for them to be launched by Photon. Again, the purpose of doing this is to create a skeleton Photon application so that we can ensure that our deployments are working correctly. So to do that, we will need some of the contents of the lib folder, but what I'm going to do is I'm actually going to take the contents of the lib folder and I'm going to copy them into my BuzzMMO solution. So I'm going to drag this over here. I'm going to right-click BuzzMMO. I'm going to say Open Folder in File Explorer. Once I have that, we'll see this. So what I'm going to do here is I'm going to jump out of source and I'm going to create a new folder at the root of my repository and I'm going to call it lib. Now inside of lib, I'm going to create a new folder called photon-server, which is going to contain the DLLs that we need to link against in order to create Photon applications. So once I'm in Photon server, now what I need to do is I need to go back into our Photon version 3.4.22 lib folder and grab only the bits that I need in order to write applications. And what bits are those? Well, we need to grab exit games logging, all of these guys. We need to grab exit game libs. I'm going to grab the PDBs and the XML files so that we get documentation of Visual Studio, as well as our debug symbols when we do debugging. I'm not going to worry about ionic zip. I don't think we need that. I'm definitely going to grab log4net.dll. Now, this is going to be an interesting thing about the way that we're going to be doing logging. All of our logging in our application is going to be built against this specific DLL. We are not going to install log4net via NuGet. And the reason is I don't want to deal with assembly redirects and other DLL conflicts when having other projects in my solution require logging. So we're just going to use the log4net DLL that's provided by Photon so that we won't get any conflicts since all of these assemblies are built against this specific log4net.dll. We don't need NUnit. We do need our photon.socket server, so we'll grab the comments.xml, the server DLL, and the DLL.config. We don't need the NUnit.dll. We do need the PDB and the XML. And in addition, we will also need photon host runtime interfaces.dll. So these are the DLLs and XMLs and PDBs that we need in order to work with building Photon server applications. So I'm just going to come up here. I have all these selected. I'm going to hit Control-C. I'm going to jump over into my Photon server folder underneath our lib folder and just hit Control-V and get all of these assemblies dumped into our project, which will be nice. So, which is a considerably more better solution than if we were going to link directly against the folders in this path. And the reason for that is that we want this development environment to work on any developer's computer. If we didn't copy these DLLs into our repository, our version of Photon would not it would be possible for another developer to have Photon installed at a different location and the paths would not line up. So remember, if you ever depend on a DLL from within an application that is under source control and is expected to be used in multiple production or multiple environments, you're always going to want to copy those DLLs into your repository. So now that we have that, let's jump into our solution and I'm going to add references. So basically I'm going to do the same steps 3 times for our BuzzMMO server, server master, and server region. I'm going to right click references, hit add reference. I'm going to select browse, and then I'm going to click the browse button. And then I'm going to locate that lib folder that we just had that stuff in. I'm just going to paste it right here. Remember, this is underneath BuzzMMO, the main repository, underneath lib, Photon server, and then we have our DLLs. And so again, these DLLs are required for the server application, not for the client application. So I'm going to grab all these, hit add. Now they're all added down here, and I'm going to hit OK, and it'll add those references. Now I'm going to do the same thing for BuzzMMO Server Master. I'm going to hit add reference. I'm going to hit browse. Fortunately, the browse window will put us in the folder that we were in previously, so I can just grab all of these, marquee select all these DLLs, hit add, hit OK. Then in BuzzMMO Server Region, I will say add reference, browse, marquee select, add, OK. So now we have the proper references set up for our server master, and our server region. But we're not quite done yet. Remember, I want this to be a skeleton application that will allow us to test if we have Photon configured properly on both our development and our production environments. So to do that, we need to put together a basic application. Now, Photon is going to require us to write at least 2 classes for each one of our server projects. We're going to need to write the application class as well as the peer class. Now, in the future, we will be removing, the majority of the code we're about to write, and we will most likely create an application and peer base class in our BuzzMMO.server project, which is shared by both our master and our region servers. But for now, I'm just going to go with the easy way out, basically, and create 4 classes. I'm going to create an application class and a peer class here, and I'm going to create an application class and a peer class here. Okay, so let's start with our BuzzMMO Server Master. I'm going to create a class, and I'm going to call it peer. There's going to be a couple requirements for this class. Primarily, we just have to have it inherit from peer base, and peer base was located under photon.socket server. If you don't have that namespace inside of this file so that you can't hit using photon socket server, that means you don't have the proper reference, or references anyway. Okay, but of course this isn't going to compile quite yet, and the reason it's not going to compile is because we need to generate a constructor. That's because our peer base does not have a default constructor. Now, the constructor that I want to override is the one that takes in an init request. I do not want to override the other one. But remember, because the peer base class does not have a default constructor, we have to write a class that invokes one of the base constructors on the peer base class. Now that we've done that, we will also run into issues because we need to implement 2 abstract methods on operation request and on disconnect. So those are going to be both protected override voids that were marked as abstract members in our peer base class. We'll leave those blank for now. I'm not going to write the implementation quite yet of what we want our basic servers to do. We'll do that later once we verify that Photon is indeed going to work. So now that I've created the peer class, we need to create the application class. So I'm just going to write new class application. Not surprisingly, application is going to inherit from application base. Now, application base came from Photon socket server, so we have to put that using statement up there at the top. And you'll also notice that we will get an error because application base is an abstract class with a variety of abstract methods that we must override. So I'm going to go ahead and generate these stubs. There's 3 methods: create peer, setup, and tear down. The only method that we have to write any implementation in at the moment is going to be our create peer method. The create peer method is simply going to return new peer. And then we're going to pass in the init request into the constructor. So again, what we're doing is we're returning a new instantiation of the peer class we just created. Okay, so that's it for our server master. I'm going to perform the same operations on our server region. Word of warning, I can already see a potential mistake somebody might make when doing this. You might say, well, I already have application peer written. I'll just copy and paste them over into server region. Well, that'll work, except your namespaces will be off. We want to ensure that our namespaces are correct because when it comes time to configure our setup and tell Photon about our applications, we need to fully qualify the path to our application class. In order to fully qualify the path of a class, we need to include the namespace. And by convention, the namespace should always, at the root of the project, be the same name as the project itself. So instead of just copying and pasting these files and changing the namespaces, I'm going to prevent all possibility of mistake, come back here to BuzzMMO server region, create a new class manually. It's going to be peer. It's going to inherit from peer base, and it's going to be exactly what we just did. But I'm just going to quickly, have ReSharper generate out those stubs for me so that I have a basic peer class with the 2 methods and the constructor that are required. And then I will also create a new class called application, and it will inherit from application base, and it'll implement these 3 methods, and it'll return a new instantiation of peer, passing in our init request. So basically, the implementation of these are the exact same, with the only one difference being that the namespace of our server region is server region, and the namespace of our server master is our server master. Now, fortunately, that's really all we need to do to get going with our Photon setup. So we've created the base skeleton for creating 2 Photon applications that we can deploy into our local Photon installation. However, when we start talking about deploying into our local Photon application or local Photon instance, we have to ask ourselves how we're going to do that. There's a couple ways to do it. We could, in theory, actually include the Photon Server SDK itself inside of our repository, making this completely 100% self-contained, which would be kind of neat. But what I'm going to do instead is I am going to have our BuzzMMO Server Master and BuzzMMO Server Region actually copy themselves when they're built into a specific folder on my hard drive on my specific Photon installation. And again, there are pros and cons of both solutions. Remember, we can either A, include Photon, the SDK itself, inside of our repository so that a new developer, the only thing he would have to do is clone the repository onto his local machine and then launch Photon, launch Visual Studio, and he would be done. Or we could require that a new developer on the team would have to go out, install Photon himself, and configure it himself in order to get it running. Like I said, there's pros and cons to doing that. Because of the amount of applications or Photon applications that I may want to write, I do kind of like having Photon be consolidated somewhere on my hard drive. Okay, so let's go ahead and get that set up. What I'm going to do is I'm going to tell BuzzMMO Server Master and Server Region to build into the folder that's on my local machine. Before I do that, though, because of the potential for multiple developers to be working on this project simultaneously, I will go ahead and create an alternative build configuration, meaning those settings that I'm creating as far as where I want these 2 things to go will depend on which build configuration is enabled. Now, this scheme works well for a small team of developers, let's say under 5 developers. If you wanted to get a larger team of developers, you would probably look for an alternative solution. Perhaps having a file that is not checked into source control, set the variable of where you want the Photon server applications to be deployed to, and then including that file from within your MS Build project itself. But we'll look at that later. For now, I'm just going to go with the simplest solution. So I'm going to come up here to Build, Configuration Manager. I'm going to come down here to BuzzMMO Server Master, select this drop-down and hit New. And I'm going to call it debug-Nelson. And I'm going to say Copy Settings from Debug. I hit OK. You'll notice that I also had the checkbox marked to create a new solution configuration. So now I have a debug-Nelson solution configuration as well. Let's go ahead and do the same thing with BuzzMMO Server Region. I'm going to hit New. The name is going to be Debug Nelson. I'm going to copy settings from Debug, but I'm not going to create a new solution configuration in this particular case because I already have that solution configuration created. Then I'm going to hit OK. So now I can make changes to the way that I build this project that are specific to my environment. Again, you wouldn't want to do this for a large group of developers, like I said, let's say more than 4 people working on the project simultaneously, but in this particular case it works out really well for us. So now that I'm at Debug Nelson as my active solution configuration and as my active project configurations for both my master and my region, I'm going to close out of this, and then I'm going to right-click BuzzMMO Server Master, go down to Properties, go down to Build on the left-hand side, and I'm actually going to change the output path to something different. Now the output path is going to be located within my actual Photon deployment. So my Photon deployment is located right here in this folder. And the folder that I want to dump it to is going to be somewhere within the deploy folder, and it's going to follow the same folder structure as the sample applications. So for example, if we open up Light, we'll see that there's this bin and this assets folder up in here, and the bin folder has this cache folder which is created automatically by Photon. So what I want to do is I want to create a sibling to the Light folder. I want to create 2 siblings actually, my BuzzMMO Server Master and my BuzzMMO Server Region. So I'm going to say new folder buzzmmo.server.master, and then another new folder buzzmmo.server.region. Now inside of both these folders I want to create an empty bin folder because that's where our binaries are going to go. So I'm going to go into Server Master, hit New Folder, and type in bin, so that we have a bin folder there. Then I'm going to open up Server Region, New Folder, Bin. So now we have an empty bin folder and for both of our Server Master and Server Regions. So now all that's left to do is to go ahead and get the full path to this bin folder for my Server Master. I'm just going to take this, copy it onto my clipboard, and then I'm going to paste it right here in my output path. So now my output path will result, whenever I build this project, in this particular build configuration, it'll deploy to that particular folder, which is the behavior that I'm looking for. So I'm going to hit Control-Shift-S, and that'll save out the project for me. Now I have that set up. Let's go ahead and do the same thing to our server region. So I'm going to right-click Server Region, go to Properties, make sure that I'm on the Build tab and that the configuration is set to Debug Nelson. And then I'm going to locate that empty bin folder right here for our server region, copy that path, paste it in here, hit Control-Shift-S, and I've now configured both of these projects. So let's go ahead and hit Control-Shift-B and see what happens. When I hit Control-Shift-B, you'll notice that these folders, these bin folders, actually now fill up with binaries. You'll notice they fill up with our bcrypt, our BuzzMMO base.dll, our data DLL, our server DLL, and our server region DLL in this particular case, as well as our supporting libraries such as our logging, our libs, and our socket server. Okay, so that's going to be true for both of these servers. So now what we need to do is we need to tell Photon about these 2 new applications so that it can launch it. And then we're going to launch Photon and ensure that it starts up properly, and then we'll know that our socket server is configured properly. So let's go back into the deploy folder and jump into our bin Win64. Again, if you're on a 32-bit operating system, you'll want bin 32. If you're on XP, you'll want one of the XP folders. But in this case, we want bin Win64 on my machine. And we're going to want to open up photonserver.config. So I'm just going to double-click here. If you don't have a file association set up with .configs, you'll have to right-click and hit Edit or Open With, and then you'll want to open with Notepad, for example. But in this case, I have config files associated with a Sublime. I'm going to set the syntax highlighting to XML because this is an XML file. And we're just going to set this up. So what I want to do here is I do want to make some changes. First of all, this TCP listeners, I'm going to disable entirely. So I'm going to take this comment and I'm just going to extend it down there, effectively disabling our TCP listener entirely because, well, we don't need a TCP listener. We only really need a UDP listener that's going to listen on 5055. And because the IP address is set to 0000, it's going to listen on all of our adapters on port 5055. Let's go ahead and do the same thing with our policy. So what I want to do is I just want to take out this comment entirely and then extend this comment to wrap our entire policy file listener so that we're not starting any policy file listeners. Our WebSocket server, I'm going to remove entirely. We may be playing with the WebSocket server or WebSocket listener later down the road. Our runtime, we want this to be there. So runtime assembly equals Photon host runtime and all that fun stuff. So that pretty much finishes most of our configuration, except for no, I don't want to take out our load balancing yet. So I'm not going to worry about load balancing. I'm just going to leave that in there. But what I do want to do is I do want to make it so none of these other applications start. We are not going to be using Light Lobby, MMO Demo, or Counter Publisher for now. So I want to basically make it so none of these start up, which will make our startup times a little bit quicker. So I'm going to remove the comments first of all. The reason I'm removing those comments is so I can take this comment and I can extend it all the way down to the bottom so that none of these application elements are considered to be in the XML file. They're all commented out. Now what we're going to need to do is we're going to need to create two application elements, one that points to our master server and one that points to our region server. So let's look at how to configure that. I am going to have to change the default equals light here momentarily, but I'll do that here in a second. Okay, so let's create an application element under the applications element. It's going to be application, and then I'm going to give it a couple attributes. I'm going to say name equals buzz MMO master. Base directory equals, now what's the base directory? The base directory is going to be the directory that the bin folder is in. So that's going to be buzz MMO server master. I don't know why my always on top is refusing to work, but whatever. It's going to be buzz MMO .server .master. That's where the folder is that contains our application. Then we need to type in the assembly. What's the assembly? Well, the assembly is going to be underneath our master folder, underneath our bin folder. The assembly is going to be the assembly that contains the application class, which if you recall is going to be our buzzmmo server master.dll. Of course, the DLL is inferred, so we don't need to include that, but we do need to say buzzmmo server.master. Next, we need type. What is type? Well, the type is going to be buzzmmo server master application. Application is going to be the class that's considered to be the Photon application, and so we have to fully qualify the path to that class by putting in the assembly name. So now you see, or the namespace. So now you see why it's important that we have consistent namespaces here. Then let's go ahead and say watch files equals, and I'll say DLL and config. What does that mean? Well, that means that the application will be automatically restarted when any DLL file or any config file changes in the directory or the bin directory. So that's going to be really nice because then all we have to do is build out our Visual Studio solution and our servers will just start. And so that's really cool. So at this point, that should pretty much wrap everything up. I do want to add the exclude files equals log4net.config. That way we can deploy log4net.config file and we can modify it, but it won't restart the application. Okay, so that's our buzzmmo master. Let's do our buzzmmo region. So I'm going to say application, open up a new application element. I'm going to say name equals buzzmmo region. I'm going to say base directory equals buzzmmo.region, or sorry, .server.region. The assembly is going to be buzzmmo.server.region. The type is going to be buzzmmo server region application. The watch files will be DLL and config, and the exclude files will be log4net.config. Now the last thing we have to do is specify a default application, which we're going to do buzzmmo master. is the default application. So if a client connects, doesn't request a particular application, it'll automatically serve them the Buzz MMO master application. Okay, so that pretty much wraps up our configuration. I believe the only way that this could fail when we start up is if you already have a program listening on port 5055 on your computer. But I don't think I do, so it should just work. Let's go ahead and jump into our deploy, our bin win32. Let's go ahead and double click on photon control.exe, which needs to run as administrator. And what that'll do is that'll add in a this onto our little taskbar. So you see the little photon stopped, it says when you hover over it. You also might see the message saying that's limiting you to 20 concurrent connected users because there was no license file found. But you know, that's fine. For local testing, 20 concurrent users is fine. For our purposes at the moment, when we do load testing, that might not be the case. But that's all good. Let's go ahead and right click this. The first thing I want to do is go to Photon Instances. I want to go to Default, and then I want to say Start as Application. Once I do that, I want to right click on Photon again and say Open Logs. And what that's going to do is that's going to open Beartail up with all of the logs that we have. Our Photon instance, actually, let me make sure, let me say close all, and then I'm going to do that again. Open logs. Okay, so this is all of our logs, and we do indeed see that there was a service shutdown complete. Oh, this is a previous log entry from earlier testing. If we look at our Photon default log, what we'll see is service is running. Actually, it looks like I forgot an attribute, which fortunately we were warned about me forgetting an attribute, because we do need to make sure that to enable the auto restart feature, we need to specify enable auto restart equals true or force auto restart. So let's go back into our Photon server.config, scroll down to our applications, and I'm going to say force auto restart equals true. And then on my MMO region server, I'll say force auto restart equals true. Okay, so now we have to restart Photon for this change to take effect. So I'm going to right click back on Photon, and I'm going to say default, and then I'm going to say stop application. In addition to that, I do want to get rid of, I'm going to go into my log folder under deploy before I restart Photon again. I'm just going to delete all these logs so that when I tell it to open logs, it won't open all that old stuff. I'll also jump all the way back down to our deploy folder, locate the log folder, and delete all of these logs as well. Then I'm going to close Beartail, move that over, right-click Photon Control, go to the default, hit Start Application, Start as Application, right-click, say Open Logs, and now you see that we only get 2 logs, our Photon default as well as our Photon CLR. And you'll see that service is now running. So you see that it successfully loaded Buzz MMO Master and Buzz MMO Region, and that's exactly what we want. Okay, now let's go ahead and write a really basic implementation of our server and our client so that we can ensure that everything is communicating properly, and so that I can show how we can give out different values for our URLs based off what environment we're in. So what I want to do is on the Buzz MMO region, when the Buzz MMO region starts, I want to have it connect to the master server, and then once it connects to the master server, it'll then tell the master server about its existence. It'll be able to know that it's at a particular location. See, if I do this dot, we have access to information that can reconstruct the path to this application. Or you know what? To simplify things instead, I think I'm just going to have a list of region server paths inside of our Buzz MMO server master configuration, and then I'll send those paths to the client when the client connects. So what we need to do here is we do need to create a configuration file for our Buzz MMO server master, but we also need to be able to have that configuration change depending on if we're building in debug Nelson mode or any other particular build configuration that we might have. To do that, it will require that we add a extension into Visual Studio. So I'm going to come up here to Tools, then I'm going to go down to my Extensions and Updates, click on that. I'm going to go online. Now I already have this installed, but let me go ahead and show it to you guys how you install it. It's called Slow Cheetah. So if we type in slow space that, we get Slow Cheetah XML transforms. And what this allows me to do is it allows me to add multiple config transforms to my app.config. If that doesn't make sense right now, it will very, very shortly. But make sure that you have this extensions installed. Remember, I got to that from going to Tools, Extensions and Updates, going into Visual Studio Gallery and searching for Slow Cheetah. Make sure you have that installed. Now, I'm going to go into my Buzz MMO server master. I'm going to right click it, go to add, new item, and then I'm going to find my application config file. Whoops, I just added something to it that I didn't want to add to it. That's not good. I added an about box, which added a reference to System Windows Forms and System Drawing. And yeah, sorry about that, guys. Just give me a sec. And yeah, okay. So don't do what I just did. Right click, hit add, new item, search for app, and then we can find the application configuration file, and then let's hit add. So the application configuration file will allow us to add configuration items. Now, what I'm going to, because this configuration, the configuration I don't believe is applied during development. I actually honestly can't remember if it is. So instead of putting any sort of defaults in here, let's go ahead and see what happens when we use Slow Cheetah to give us a transform. So what I'm going to do is I'm going to right click my app.config, and you'll notice this button called Add Transform. The Add Transform button will appear only if you have Slow Cheetah installed. And it says that in order to support transforms, your project file will need to be modified. This will cause your project to be unloaded and reloaded. So that's exactly what we want to do, so we'll hit yes. And then I have to hit reload all because it's been modified outside. And what that did is now I have this little drop down here on my app.config, and I'm able to create a custom application transform based off of if I'm building for any one of these configurations. So let's go into my root app.config and throw in a default value. Under configuration, I'm going to create app settings. Under app settings, I'm going to say add. Let's give it a key of region servers and a value of, let's just do a comma separated list of IP addresses. So I'm just going to do 127.0.0.1:5055 for the port. So that's just going to be, I only have one region server here. So when I connect, I will be connected to this particular server. So we'll make this a little bit more interesting in the future. But for now, this will serve our purpose because all we want to do is print out or send this to the client so that the client can then connect to the region server for our testing to ensure that both servers are configured appropriately. Now let's go ahead and override this setting. Actually, for testing this, I'm going to leave this as blank, and then I'm going to go into the app.debug Nelson, and I'm going to create an override for that value. So this file, this transform, is applied to this file, this app.config, when I build for this particular configuration, the debug Nelson configuration. So the syntax of transforms are pretty straightforward. Let's go ahead and do that. I'm going to come down here into configuration. I'm going to open up app settings. Then I'm going to say, so this is going to be really cool. I'm going to say add key region servers space value equals 127.0.0.1.50.55, but I'm not done yet. What this does is this won't do what you expect it to. This will actually do nothing because we're not specifying how exactly we want the web or the app config transforms to happen. We're not specifying that we want to, I don't know, replace this setting, delete this setting, update this setting. We're not telling it what to do. And furthermore, we're not telling it how to locate this setting. So to do that, we need to specify two additional attributes. We need to specify xdd : and then transform. And the transform is going to be set to set attributes. That means this element, when it's matched against an element in the base app.config, these attributes will be applied to that element and replace them. Now we need to do the locator. So we have our key, our value, and our transform, but we haven't told it how it wants to locate this element or how it should locate this element. So I'm going to type in xdt : locator equals match on name, or sorry, match on key. So what does this do? Well, the locator attribute says, okay, the way that I want you to map this element in my transform to this element in my base config is I want you to find an element inside of app settings of type or called add where the keys match. So basically what's saying these two lines combined say find an element in my app settings element that has the key of region server or region servers, and then set this value to whatever we have in the transform. Let's go ahead and hit F6 to do a build. We notice we get a build succeeded. And then jumping back into Explorer, let's look at what was actually deployed. So coming into our Photon server, which is right here, jumping into our deploy folder, let's locate our buzz MMO server.master is the one that we want. Let's open up bin. Now let's open up our buzz MMO server master dll.config and see what we get. And as you see, the config we get is 127.0.0.1.50.55. Again, why do we get that? Well, we get it because we're building in the debug Nelson configuration, and we're overriding that setting with what was found in the original app.config. So this allows us to put configuration values for all of our different environments. So what I want to do here, though, is I do want to delete the app.debug.config. The reason I want to delete that is it's practically useless. We're never going to be doing app.debug or we're never going to be doing debug builds. We're either going to be doing debug Nelson builds or release builds. So that transform is kind of worthless. We don't really need it. Again, we can do the same thing by opening up our release configuration and giving it a whole nother set of settings. Okay, so what I want to do is I want, when a person connects to the master server, I want the master server to send them region servers. I guess before I do that, though, I want to go ahead and just create the transforms for my BuzzMMO server region, just so that we have those transforms in place when we move on to other things. So I'm going to right-click BuzzMMO server region, go to Add, New Item. I'm going to select Application Configuration File right here and name it app.config, hit Add, right-click app.config, hit Add Transform, hit Yes to proceed, hit Reload All to reload the project now that it's been modified. I'm going to open up Expand app.config and I'm going to delete app.debug. So now we have a proper setup for our app.config with our app debug and our app release. So this is a really cool way to change configuration settings depending on where you're building something. We'll see another way to change configuration settings later in another video when we talk about deploying websites. But For right now, this is all we need. So again, what I want to have happen is I want the BuzzMMO server master, when a peer connects, I want that peer to simply send this information, this region servers. So how do we do that? Well, let's jump into our peer. Inside of our constructor, I'm going to just simply write send event. The event data, I'm going to instantiate a new event data. The event code is going to be 0, and I'm going to pass in a new instantiation of a dictionary of byte and object. That's going to require that I bring in our system collection generic. I will be using collection initialization syntax for this, but I'll leave that empty for now because we have one more parameter that we need to specify, which is our send parameters. I'm going to instantiate a new send parameter struct and then use object initialization syntax to set unreliable to false. Now that we're sending an event back to the client that just connected, we need to fill it in with some data, and that data goes inside this dictionary. So I'm going to enter a new line on this. Actually, I could probably make this a little bit more clean if I did that. I think that's a little bit more consistent. So we have our data that we have our event code that we're sending, which is just 0. We have our data that we're sending, and then we're instructing it to send it reliably. So what data are we sending? Well, let's go ahead and open up some curlies, have a key of 0. Then what's the value? Well, the value is going to be configuration, I believe configuration settings. It's configuration manager. And configuration manager is an assembly that we haven't referenced yet. You'll notice that it requires me to reference system.configuration. For the people who might not have ReSharper installed, I'll show you guys how to do that manually. Come over here to BuzzMMO Server Master, right-click References, hit Add Reference, go to Assemblies at the top, and then search for system.configuration. And we see system.configuration right there. We'll check that box, hit OK. Now we have access to the configuration manager, which is imported in by using system configuration. So we can say configuration manager, app settings, and then we're going to index it on region servers. And this will effectively send the value of region servers to the user, or to the client that just connected, so that he's now aware of the region servers so that he can go out and connect to those region servers. Again, we're going to be nuking pretty much all of this code that we're writing later down the road, but we need this in order to be able to test that things are getting deployed properly. All right, let's go ahead and hit F6 to make sure that our servers are up to date. You'll notice that when you hit F6, if you have Beartail still open, you'll notice that the app domains are being unloaded and then reloaded. So that's exactly what we want to do. Okay, so now let's go ahead and work on our client. So the first thing that we need to do is we need to remember that we downloaded those client SDKs at the beginning of this video. So let's see here. Let's go ahead and pop open our lib folder of our solution. So I'm going to right click on BuzzMMO, say, let's see here, open folder in File Explorer. And we see this right here. Let's back up out of source and then open up lib. And then I'm going to say new folder, and I'm going to say Photon client.net. Inside of Photon client.net, I'm going to extract the Photon on-premise.net SDK, which is right here. This is the contents of that file that we had previously downloaded from the Photon website. So you'll see that it does contain a bunch of nice little, that's new. So it does contain nice little samples, and that's pretty cool. But what we really care about is inside of libs, we want to grab the release, and we want to grab Photon3.net DLL and XML, and we want to drop them right into our lib Photon client.net. Then we want to back out to lib, add a new folder, and type in Photon client unity. And we're going to do pretty much the same thing. We're going to open up Photon on-premise unity3d.stk, which shows us this. We want to open up libs, open up release, and we just want to plop in Photon3 unity3d.dll. So now we have our client Unity and our client.net. Now what we need to do is we do need to make sure that our client Unity project is referencing our proper assembly. So to do that, let's go ahead and right-click References, hit Add Reference, and I'm going to add a reference to, I'm going to select Browse, I'm going to hit Browse, I'm going to go into the lib folder and add a reference to Client Unity, and say Photon3 Unity 3D, and hit Add. Why are we adding it to MMO Client Unity? Well, MMO Client Unity is going to need to be able to reference that code, but in addition, that DLL needs to be copied into our Unity project, our client Unity project. And by adding it as a reference to our BuzzMMO Client Unity, which is built into our Unity project, and ensuring that, let's see here, copy local is set to true, this will bring the Photon3 Unity 3D DLL along for the ride and plop it into Unity. Okay, so now that we've done that, I'm going to open up buzzmmo.client, and I'm going to add a reference to photonclient.net. I'm going to hit OK. Okay, one more thing. This build info, I do need to add a link to it in my buzzmmo.client.unity. So I'm going to right-click buzzmmo client unity, I'm going to hit add, I'm going to say existing item. I'm going to jump out of source into buzzmmo.client. I'm going to select build info, and I'm going to say add as link. Now remember, buzzmmo.client and buzzmmo client unity are closely related projects. They're mostly going to contain the same code. The difference is that buzzmmo.client is going to be built against Photon3.net DLL, whereas buzzmmo client Unity is going to be built against Photon3 Unity 3D DLL. In order to not have to copy and paste a bunch of files, basically what we're going to do is the files that are shared between client and client Unity are going to be added as links, so that this is a reference to this file. So that when we build BuzzMMO Client Unity, the files that we want from BuzzMMO Client will be included, but they'll be built against a different Photon DLL, allowing it to work in Unity. I'm also going to ensure that this is indeed being deployed into the right folder. And you'll notice that the BuzzMMO Client Unity is not being set, or is not set to the path to our client. So let's go ahead and open up Explorer, back out into BuzzMMO, open up the Unity folder, open up the client folder, open up Assets, and then I'm going to right-click anywhere in here, and I'm going to say New Folder, and I'm going to call this Assemblies. So remember, these are the assets of the actual Unity project. And I'm going to grab this whole path, and I'm going to copy it, and then I'm going to paste it here into the output path, and then hit Control-Shift-S. So what's really cool about that, though, is if I come back here, if I close out of that file and reopen it, you'll notice that the output path changed from an absolute path to a relative path, meaning that this path will work no matter where we clone our repository to. Okay, so let's go ahead and hit Control-Shift-B. What is that going to do? Well, you'll notice immediately it's going to cause our Unity Client Assets folder, assembly folder, to contain our BuzzMMO Client Unity and our Photon3 Unity 3D, which is exactly the behavior that we're looking for. Alrighty, so let's go ahead and pretty much wrap this video up by creating a very basic client in Unity that we can use to test connecting to both our master server and our region server, just for purposes of testing, basically. So I'm going to come up here to our Unity client folder. I'm going to copy this path. I'm going to load up Unity. I'm going to say open project. I'm going to say open other. I'm going to paste the path, hit select folder, and we now have Unity starting. And now you'll see that indeed we have our assemblies folder. So what I'm going to do right here in my project window is I'm just going to say create C# script, and I'm going to say test photon is what I'm going to call it. Then I'm going to double click it to open it up in Visual Studio and wait a year and a half and hope that it actually loads up Visual Studio instead of MonoDevelop, because sometimes it's like, we're opening in Visual Studio, but then MonoDevelop comes up and I get really angry. It actually did open up Visual Studio. That was nice of it. Okay, so let's go ahead and remember, because we copied those assemblies into our assets folder, you'll notice they're added as references here. So we can now reference our base, our client Unity, and our Photon 3 Unity 3D. So my test Photon script, I'm going to remove all the code out of it. And I'm just going to write this out really quickly. Again, this is just for testing purposes. I'm going to say public void awake. I'm going to say underscore peer equals new photon peer, and I'm going to pass in a peer listener of this and a protocol type of UDP. I'm then going to have a private photon peer local variable brought in here. Or a private field. You'll also notice that using exitgames.client.photon appeared at the top. In addition, I want this mono behavior to implement iPhoton peer listener, which will require that I implement 4 methods: debug return, on operation response, on status changed, and on event. So let's worry about implementing those here momentarily. Once I instantiate my peer, I want to say peer.connect. I want to connect to 127.0.0.1:5055 with the application name of Buzz MMO master. Then I want to say public void update, and I'm going to say peer.service. Then I'm going to say public void on application quit peer disconnect. Okay, so that's all well and good, but we're not yet connecting to our region server. We're only connecting to our master server. So what I want to do is I want to do a couple things. I want to say on status changed, I want to say debug log status changed : and then we'll format string this, say status code. Then I also will need to create another photon peer to contain the reference to the photon peer for my region server. So I'll just say, I'll get a little fancy with this. I'll say list of photon peer region servers. And I'll say region servers equals new list of photon peer. I'll bring in system collections generic at the top. Then on my on event will happen when we connect to the master server and the master server informs us of our region servers. I'm not going to do any error checking here. I'm simply going to say var region servers equals event data dot parameters at 0 dot toString dot split on, I don't know, comma. And I'm going to say for each var server in region servers, var region server equals new photon peer, passing in this as the listener and UDP as the protocol. I'll say region server dot connect at server, comma, buzz MMO region. Then I'm going to say region servers dot add region server. The last thing that I need to do is I need to make sure to service my region peers and disconnect my region peers. So on my update method, I'm going to say for each var region server in region servers, region server dot update, or sorry, dot service, and then on application quit, I'm going to say for each var region server in region servers, region server dot disconnect. Again, just code that we're going to literally be throwing away down the road, but enough here to ensure that our Photon servers are properly connecting. Of course, we'll worry about in a later video how we're going to handle this configuration right here to ensure that our clients connect to the appropriate master server. Okay, let's fire up Unity, and let's go ahead and add test photon to be a component of our main camera. And then I'm going to hit play. And there you go. Status change connect, status change connect. Status change disconnect, status change disconnect. That means we connected to the master server. The master server sent us a list of all of the region servers, and then we connected to that region server. So otherwise we wouldn't have gotten 2 connects. Okay, so yeah, a bit of a long video, but what we accomplished was quite a bit. So we got Photon installed, we got it configured and working, we got our BuzzMMO server master and server regions being built out to the proper folders, we found a way to handle changing the configuration based off of, or the configuration values, our settings, based off of our current build configuration. We then wrote a simple application that sent a list, or our master server sent a list of region servers to the client. We then got our client project, our client Unity project set up properly, and we ensured that we can indeed connect to both the master server and the region server. Now that we have all of this in place, really the next thing that we need to do is come in here and finally implement our deploy photon task. So our deploy photon task will perform the proper synchronization of our builds to particular folders that can be specified by the build environment. So I think this pretty much wraps this video up, and we'll see you guys in the next one.